integer exponents. Is there anyone can tell me what is the integer numbers? What is the integer numbers? Yes, ya Magdi. Magdi, you are raising your hand. What the meaning of integer numbers? It could be a decimal
Yes,
number.
answer.
Yes. Yes, please. Integer. It has decimal or fraction. Integer numbers.
It has the negative numbers or
Mm.
positive numbers with zero in the middle.
Yes, thank you so much. It has a positive and negative numbers and zero. It doesn't have decimal or fraction numbers or fraction numbers. Then exponents. So let's watch now, and I'm going to stop the video and I will ask you anyone. So please being attention.
Let's start with defining exponents. Some books or your teachers may call an exponent index or power from time to time. They will.
So how many words we can express exponents? We can see the word what?
Power
Index
and
and power.
Power, index, and exponents. All of these words have the same meaning.
All mean the same. You can think of exponents as a shorthand way of expressing.
Farah, do you have a question, honey? Mahlab.
No, I just wanted to answer before.
Okay, thank you, Habib. Let's concentrate.
How many times you have to multiply a base by itself? The base can be as simple as a single digit number. For example, 5 raised to the 4th power is equal to 5 times 5 times 5 times 5, or 625. The base can also be as complicated as an algebraic expression.
In this question, is this something new?
No.
We studied this before, right?
No.
5 to the power of 4. Which one represent the base and which one represent the exponents? In this example in front of you, we have 5 to the power of 4, right? Which one represent the base and which one represent the exponents?
5 is the base and
Exactly, 5 is the base and the exponent is 4. What the exponent means here in this example? What is the
That will
exponent?
multiply
time.
How
Multiply
many
5 by
times?
itself
Yes.
4 times.
How many times we are going to repeat the base? So we have 5 to the power of 4. So it's 5 times 5 times 5 times 5. And the answer, it will be 624. So this is with integer exponents, the first example. Let's continue.
For example, x plus y to the 4th power is equal to x plus y times x plus y times x plus y times x plus y. Doing the nitty-gritty of expanding it will result to x to the 4th power plus 4x cubed y plus 6x squared y squared plus 4xy cubed plus y to the 4th power. We will be spending a lot of time solving a problem, but we always have to expand mathematical expression. So knowing how to use exponents is a powerful, time-saving, and friendly way to solve math problems.
So why we have to use exponents? Why we have to use exponents?
Because it's easier.
It's easier, and we can write the answer in. Listen to the last sentence. Be careful, please. Listen.
How to use exponents is a powerful, time-saving, and friendly way to.
So it's
Shortened form.
it's shorthand form and shorthand form, and it will save your time. Okay, for this reason we have to study exponents. Let's provide the properties.
Problems. The properties of exponents might seem a lot at first glance.
So These are the properties of exponents which we studied before last year, right? So please look at the properties which in front of you now. K to the power of 0. K to the power of 0, any number to the power of 0, even if it was short or long, any number to the power of 0 should be equal how many? Should be equal 1, right? K to the power of 1, which means you are going to repeat the base only one time. So you have in your right hand, you have example for each properties. Then 4 to the power of 1, it will be equal 4. K to the power of -1. Any number with a negative exponent, if we want to change it into positive, so we are going to transfer it to the denominator. So k to the power of -1, it will be 1 over k. Then let's take an example. 4 to the power of -1, it will be how many? 1 over 4. Properties number 4. Property number 4. K to the power of -n. You have a negative exponent, and n is the number. You can replace it by 5, 400, million, whatever. But once you have a number with a negative exponent, to simplify to be positive, you have to transfer it to the denominator. Then 4 to the power of -3, it will be equal 1 over 4 to the power of 3. K power 5 times k power n. You have to note that we should have same what? Same what, grade 9?
Exponent. The
No,
variable.
same if you have k power m times k power n. So we have the same base, right? Then once you have the same base and we want to multiply, so we have to add the two exponents together. Then, for example, 4 to the power of 3 times 4 to the power of 6. So we have 4, and we are going to add 3 plus 6. It will be equal 4 to the power of 9. K to the power of m over k to the power of n. We have the same base, and this is division. So we are going to subtract the exponents. So 4 to the power of 7 over 4 to the power of 5. It will be 4 power 7 minus 5 equal 4 to the power of 2. Also, we have a raising power, k to the power of m all to the power of n equal k, and we are going to multiply the two exponents together. So it will be 4 times 3, it will be 4 to the power of 12. When we have two variables inside the parentheses and we have an exponent, so we have to distribute the exponents over each one. Then jk all to the power of m, it will be j power m times k power m. We have 4 times 5 all to the power of 3, so we will distribute 3 over 4, 4 to the power of 3 and 5 to the power of 3. The last one, j over k all to the power of m, then we are going also to distribute the exponents over the parentheses with the numerator and denominator. So we have an example, 4 over 5 all to the power of 3 equal 4 power 3 over 5 power of 3. Okay, any question? All of this, is there anything new? We studied all of this before, right? What is the part which we are going to study it? Let me show you an example first about the negative exponents.
How many times you have to divide 1 by the base number? Third, a fractional exponent like 1 over m means to take the mth root of a number.
This is our lesson today, 4 power third. This is called fractional exponents, which we are going to talk about it by details after a while. So our lesson today is what? Did you study this one before? Fractional exponents? Nagdi,
No.
did you study this one before? Fractional exponents? We studied what before? What did you study last year and we revised? Integer exponents, which the exponent, it could be positive or negative or 0. Okay, but this one is called fractional exponents.
For example, 4 raised to the 1/3 power is equal to the cube root of 4. This will be tackled more in a different video. Now that you've been briefed, it'll be much faster and easier for you to understand the properties of exponents in detail. Let's start with the first three properties of exponents. Any number raised to 0 power is equal to 1. It doesn't matter if the base is very small or if it is a million. Raising it to the 0th power will still result in 1.
How we can solve this?
We're gonna flip the fractions.
Yes, we are going to flip the fraction. So we have 3 out of 4 or 3 over 4 all to the power of -2. Then it will be 4 over 3 to the power of 2. Okay, so once we want to change the number from negative into positive, we are going to flip the fraction. But let me give you another question. A to the power of -2 all power -3 times a power 5 all power 2. How we can simplify this fraction? What is the first step? يلا فرح. Okay, فرح محلى.
We're gonna multiply the exponents like -2 times -3.
Exactly,
So it's gonna
because
be
here we
8
have
over
raising
6.
power, right? 8 to the power of -2 and to the power of -3. Then it will be what, يا أدهم?
It will be to the 8 to the power of 6.
Yes, it will be 8 to the power of 6. Okay? Then, Farah Hashim, what is the next step? What is the next step? Farah Hashim.
Yes, yes.
What is the next step, ya Farah? Farah Mahlab said that we are going to multiply -2 times -3, right? It will be 8 to the power of 6. Next, we have 5 to the power of 2. Then 5 to the power of 2, it will be, 8 to the power of 5 to the power of 2. We will multiply together. So we have 8 to the power.
So it will be 25.
No, it will be 10.
Sorry, 10, yes.
10. And then we have 8. And then what we have to do, 8 to the power of 6 times 8 to the power of 10. It will be what?
We will add the exponent.
We will add the exponent, so it will be 8 to the power of 16. Right?
Yes.
So this is how we can use the properties of exponents to use it to simplify the questions. Let's move to the next part, which is exponential properties. So what is the exponential properties or
those positive numbers, but we never looked at fractions as exponents.
So rational exponents means that we are going to find a fraction as an exponent. Right? So before we started if it's positive, negative, 0, but this time we are going to study fractional exponents, A over B. Then how we can solve a question
For
like
example, if we have something like 4 to the exponent 1 over 2, what would that be? It's certainly difficult to understand what this would mean, but there is another equivalent form that might help us to understand what this means. Now, this over here is equal to this. So notice.
So what do you notice here? If it was 4 to the power of half, we can write it in another form. It will be exactly the same like square root 2, 4 to the power of 1. What do you notice, grade 7? Grade 9.
The half is separated.
We separated. We changed already. once you have exponents, rational exponents, which means we can change the number into with a radical sign. Did you see this one? This is called radical sign. We will put the denominator out and we will put the numerator inside at the power of this number. Then 4 to the power of half, it will be square or the radical sign 2 and then 4 to the power of 1.
How this exponent over here has a numerator of 1 and a denominator of 2. What we end up with is square root of 4 to the exponent 1. So once again, you can see that from the exponent, the denominator is what determined the degree of the root. Of course, since the denominator is 2, we have a root of degree 2, more commonly known as a square root. And since the numerator is 1, we are looking for the square root of 4 to the exponent 1.
Understood the last part? Could you please anyone repeat? Hannah Yasser.
Yes, Miss Sahar.
Hannah.
Yes.
Yes, Hannah. Go on. If you have a number.
Yes, can you say that again?
Yes, if you have a number with rational exponents, which means it's a fraction, how we will change it into root. So we will look at, you can tell me.
We will get the, yes, I did it because the internet was just cutting. So I didn't hear you, sorry. We will get the denominator and turn it into a square root or
the degree of the root. Yes, so the denominator, yes, then, it will be the degree of the root.
Yes, and then we'll get the numerator and we'll put it as an exponent.
Thank you so much. Thank you. Let's continue. Thank you.
And of course, the square root of 4 can be further simplified to 2. Great. So if we had something like 16 to the exponent 1 over 2, then this would...
How we will change this one into a root? How we explain this one into root? Huh?
Square root 2, 16 power of 1.
Yes, very good. Square root 2, 16 to the power of 1, which means the answer it will be how many? The answer it will be how many? It will be only equal 4. So this is the rule which we can use it with all the questions. X to the power of A over B. Abdullah, the denominator means what, ya Abdullah? Abdullah.
Yes, miss.
The denominator means what, ya Abdullah? Represent what?
Represents
Abdullah, please be careful. Many times I asked you and you didn't concentrate at all. So please, A over B as an exponent. Abdurrahman Abu Talib. Abdurrahman Abu Talib.
Yes, miss.
Could you please tell me, B, donate for what? B. Welcome in the group. Salma? Salma? Yes. Could you please tell me B, donate for what, ya Salma? Debolina? Sorry, Bomika? Bomika? Bomika?
Yes, Miss Sahar.
Could you please answer my question?
A fraction of exponents.
It will be, represent what? It will be degree of the root. It will be degree of the root. And the numerator represent the power over the base. Okay?
And what is happening to A. Now, with that in mind, let's try another example where we specifically try to use this general formula. And you'll notice that it's actually really easy to do. So if we had something like 32 to the exponent 3 over 2, that would just be the square root of 32 to the exponent 3. If it helps you to understand exponents better, another way to do this would have been to see this situation, where you, of course, you see the square root of 4. Higher power right here. Awesome. This isn't actually to do is deal with the operators. Negative 12 over 7 plus 2 over 7. Well, that's pretty simple. That's just going to be negative 10 over 7. Now the question is, what do we do from here? Well, we have already learned what to do.
The same way we are going to
the
use
exponent 10 over 7. Remember, we can just do 1 over and take that entire power, dropping that negative sign. Great. Now we're almost finished, but we did learn something today. We can put that 18 to the exponent 10 over 7 in a different
So we
form.
can't use
Do
the
we
negative
need to?
exponents. You will
Maybe
change
not.
it into
But if our
positive
teacher
first,
wants
and then
us
you will
to,
change it
then maybe
into
we should.
root.
So